Alright, hello everyone, this is Mr. Croge. I want to give you some help here on page 4 of your review packet. How many triangles are possible? Well, remember that's the case where you want to draw the triangle with the angle given down here. So always put that angle down there. And then the A is the one across, and we want to put the other B value up there. So, and again, this side out here is 7, but we don't know where it goes. So what we do is we find the height. So you can find the height with sine of 27 equals the height over the B value. Finding that height will tell you what this is. Then you can use that 7 to determine whether it's right at 1 or if it can fit in between there or if it has to go out that way. On the area of a triangle here, well, you have enough information to use AB times cosine of big C, because you know an angle and then 2 sines on the opposite. The formula here, the semi-perimeter, add them up. What is that? 21 divided by 2, that'll be your S value. Then S minus 9, S minus 5, S minus 7. Do that all in your calculator, write it down, take the square root. Draw the angles, 0 of course here, negative 140, go to the left, 7 pi over 8, well that's almost 1 whole pi, and remember this is exactly 1 pi. So divide this up into 8 parts, go 7 of them. 2 radians, remember 1 radian is about 57.3 degrees. Then 2000 degrees, well that's a lot of 360s. So how many 360s are in there? That'll give you how many turns. On this one, you're going to have to go multiple loops around here. Every loop is 360. Then you'll have some left over. Down at the bottom, the degrees to minutes here. Remember we have 0.29 times 60, and then the leftover decimal times 60 again, and this one is 1350 60ths plus 25 seconds. Those are minutes, those are seconds. The perimeter, well, you can definitely use SOHCAHTOA on this one. Find that side and that side, add it with 9 for the perimeter. On these ones, we're not told where theta is, so if we're not told, you are allowed to make the assumption on this packet that it's just a first quadrant triangle, so you can just draw a basic triangle. Opposite over hypotenuse, well that's a 3, 4, 5, then find the tangent. Same thing here, but when you do this one, you're going to have opposite over hypotenuse, or sorry, opposite over adjacent, and then this over here is going to be a radical, and you're going to use the Pythagorean theorem to find out that hypotenuse. So it will be a radical. Same thing here. Remember, we're not good with secant, so I think a lot of us, we see it better like cosine. Now we do have a sine value, but we know the quadrant, so we can't just draw a triangle. We have to make sure we draw it in the right quadrant. So it has to be over here, and what that does is it makes this value negative. So whatever you have here, and it will be a radical, needs to be negative. Maximum value on a graph. Well, if you remember anything about graphing, this negative 1 is the midline, so we have a midline down here at negative 1, and then the amplitude goes up 4, so from here we go up 1, 2, 3, 4, so there's our maximum value, and our minimum would be negative 1, 2, 3. So this graph goes up and down in between here. And what do we want for a maximum value? Well, the maximum value is the output. I'll give you this answer. The answer is just 3. That's the highest output. When we say the maximum value, we're talking about a y value, not the x. And this last one, well, you could just punch it in a calculator and you get the answer. But this will be a non-calculator problem, so we need an exact answer. So we just go back to the basics and we draw this triangle. 5 cosine 6, and then you have that angle. Now take the sine of it. So what's the sine? Well, sine is the opposite over the hypotenuse. And again, this is a non-calculator problem. You'll get a radical there. Alright, I hope this helps you get through page number 4.